All right, let's go ahead and get started. First thing guys should be paying attention to is your Moodle site. So I just kind of opened the Moodle site up and tried to explain it. So I'm finishing up section 7.5 today and also doing the last section, which is 8.1. Now, I know the material for this upcoming test looks like a lot of material because it's chapter 5, chapter 6, chapter 7, and chapter 8. But that's a misnomer because chapter 5 only had like 3 sections in it. Chapter 6 only had 1 section at 6.1. Chapter 7 had more sections. It had 5 sections in it. And then chapter 8 only got 1 section in it again. So it's not as many sections as you think. So it really does break out into about the last third of the class here. And so as I've promised and posted up here, here is your homework number 3, which is due when? Friday. Of course. Why Friday? As that makes test on Monday. Okay, so as you were anticipating, and it was also announced for you guys, but I put it there. So here is your homework set. Now, once again, I've made it a little bit longer homework set, but the purpose of making it this is because I'm trying to throw every possible kind of question I can at you guys. And then from this collection, I'm going to kind of narrow it down a considerable amount to do a test that you can do way less than 75 minutes and stuff. So this is a good all-around homework set. So if you master this, you should no doubt be making huge A's on the test. Because you know how my tests are. This is why I give you guys traditional homework sets. But in conjunction with the test being on Monday, you also have, as we always do with tests, we also have our web test part. And the web test is up. I believe it is running for those people that attempted it. We were just polishing it up, and I didn't realize that people already had access to it and started taking it and stuff. But it's up and running now. If you want to take it early, go ahead. But the goal is to take it before you have your test on Monday to help you kind of also prepare for that. So, all right. And of course, on the rest of this thing here is also the university has just announced that you guys are supposed to do your course evaluations online. So please come over here, and all you got to do is click on this link here and go sign yourself up for the course evaluation. And being this is one of these redesign courses, I really am interested in your opinion. So please come and take this particular evaluation of the course, and let me know what you think of the course in general, what you think especially of the Hawk system. And granted, it was a ton of work to do, but the goal is if you do more work, you get better stuff at it, and hopefully you see your grades improving and stuff. And of course, you have all the information about the cumulative final exam. First off, our review for the final exam, I'm going to go over and do last semester's exam, and there it is right there. And only I have this thing up for you guys. So if you have a friend that wants to come to our review session, invite them. That's fine. But you're going to have to give them an extra copy of the review, the spring 2015 exam, because no one else has this thing out there. Like I said, the review is on our reading day, December the 10th, from 2:30 until 5. And it'll be in here. But the final exam will be in Fretwell 121, just off the hall, which is on Friday. Not this Friday, the following Friday. The Fretwell 121, beginning at 8 o'clock, which pretty much bites because that's when you open your test booklet. You've got to be there early because you've got to fill out a bunch of forms. So you got to bring your student ID card, and you got to fill out a bunch of forms. So you guys need to be there about 7:30, 7:35 or something like that. Make sure you get your seat. You're all set up, and I'll be passing stuff out. And then right around 8 o'clock, you guys will have everything that I'll say, go ahead, open your test booklet. And then you've got 3 hours of sheer enjoyment to take the departmental cumulative final exam. All right, so let's go ahead and get started on the second to last section, which is kind of a combination of everything, tying it right back together, which is combinations of logarithmic and exponential equations. What it all boils down to is how to solve these logarithmic and exponential equations. Well, as I mentioned to you guys before, we have lots of properties on logs, but these are your big properties right here. The first property is what I call the smiley face definition property. If you ever have y equals log base b of x, and you need to figure out what's going on and you don't quite get a good handle on logs, you always have the ability to rewrite a logarithmic equation. You have y equals the log base b of x. You're going to have one log in this thing. So when you do, you start with the base b, you raise it to the other side, it is equal to what you're taking the log of. That's where you get the b raised to the y equals x. This exponential equation and logarithmic equation are the exact same equations. The other property is this. When you take the log base b of b raised to the x, exponentials and logs are inverses. They'll knock each other out and you're left with x. Similarly, if you have b raised to the log, that's supposed to be base b of x, it'll be equal to x. So on special logs like this, what is the natural log of e to the x? What do you think you're going to get there? Natural log and e's are inverses. So what are you going to get? They cancel. You're left with x. Natural log and e's cancel. Similarly, e raised to the natural log of x, that's also equal to x. If I had base 10, then that'll be common log of 10 raised to the x would be x, and 10 raised to the log base 10 of x would also be equal to x. Multiplication turns into addition. You can go backwards and forwards on these log properties. Question? Yeah.
Can you zoom in a little bit?
Sure. Multiplication turns into addition and back again. So if you got a single log of multiplication, that'll be the log base b of m plus the log base b of n. And don't forget, you can go backwards and forwards. Addition, if you're adding, turns back into multiplication. That'll be 1 big log base b of m times n. Multiplication turns into addition and vice versa. Division turns into subtraction and vice versa. And numbers in front of the logs go back as powers because powers get to be stuck in front of the logs. These are your classic big three properties on logarithms. So, our goal here in this particular section is to solve exponential and logarithmic equations. Okay? So, here's your first problem. 2 raised to the x equals 12. Your mission in life, solve for x. Where's x located at? It's in the exponent. There's only one thing in the universe that brings down exponents. What's that? Logs. And there's several different ways I can do this particular problem. So it really depends on if it's a multiple choice question. I'm going to look at my answers and see which way do they kind of do this one. So I'm going to do this problem in pretty much 2 different ways. I guess I can do it in 3 different ways. All right. Because the variable is in the exponent and I've already got it by himself, I need to use a log. The question is, which log should I use? Well, because the base on the exponential is 2, I could use log base 2 of this guy. I could take the log base 2 of 2 to the x would be equal to the log base 2 of 12. Why did I choose log base 2? Because the base on the exponent was base 2, 2 to the x. And according to log property number 2 here, log base 2 of 2 to the x, what happens to log base 2 and exponential 2 to the x's? What do they do to each other? Cancel. What are you left with? They'll cancel, and you're left with just x is equal to the log base 2 of 12. And that's my answer. But if the answer set didn't have this as one of the answer choices, maybe they did this. 2 to the x equals 12. I could do this another way. They want me to calculate this guy in terms of a decimal type of thing here. In terms of my calculator, how many log buttons do I have on my calculator? There are 2 major log buttons here. The common log and the natural log. The common log, log, is log base 10. The natural log is log base e. When do I use a natural log? When I have an e in the problem. Do you see an e in this problem anywhere? 2 to the x is equal to 12? No. So if I want to calculate this thing out, my rule of thumb is I'm going to use the common log because there's no e's in this problem. So I'm going to just take the log of both sides. The log of 2 to the x is equal to the log of 12. Well, this is base 10, so they're not the same bases as my exponent, so they're not going to cancel. But I do have property number, I guess the way I wrote it up here, property number 5. Where do exponents get to go? To the front. So the exponent pops out front. That gives me x times the log of 2 equals the log of 12. And then how would you solve for x? Log of 2 is nothing but a number now, some crappy number on your calculator. How are you going to solve for x? This thing's being multiplied, so you would divide by the log of 2 on both sides. This cancels, you're left with x is equal to the log of 12 over the log of 2. So both of these two answers are exactly the same way, but there's two different ways of actually writing the answer. But this is the nice way that I can actually plug it on my calculator and get the decimal version of it. Log of 12, close parentheses, divided by the log of 2, close parentheses. The answer for x is an interesting 3.584962501. And then I can prove my question. This is what I got for my answer. So if I go and do this, remember the original equation? 2 raised to the x equals 12. If I take 2 and raise it to that 3.584962501, what number should I get if I hit enter? Yep, that's pretty much what I got. So this is the correct answer. So this is the cleaned up form of the answer. This is the calculator form of the answer if I actually wanted in decimals. Let's take a look at problem number 2. What do you notice about this guy? I've got e raised to the 7x plus 3 equals 5. One, it's an exponential equation. The variable's in the exponent. Big old x up there on the. But what's the base on this exponential equation? E. Now there's only one thing in the universe that brings down exponents. What's that? Logs. What kind of log will I use on this problem? Natural log. Anytime you've got an e in the problem, you want to get the e by himself, which in this case it is. I'm going to take the natural log of both sides. So the natural log of e to the 7x plus 3 is equal to, what I do to one side, I do to the other, the natural log of 5. E's and natural logs do what to each other? Cancel out. So this cancels. I'm left with 7x plus 3 equals the natural log of 5. Mission, solve for x. How am I going to solve for x? Natural log of 5 is just some kind of crappy number, just a number on your calculator. To solve for x, I'm going to subtract 3. These are not like terms, so don't try to combine them. That cancels. That leaves me with 7x is equal to the natural log of 5 minus 3. Then what's my last move to solve for x? Divide by 7. What I do to one side, I do to the other, and that's my solution. X is equal to the natural log of 5 minus 3 divided by 7. Again, at any time, you can put this on your calculator and go for that decimal version of the answer. But to be able to do that, you've got to put parentheses around your numerator. Parentheses, natural log of 5, close parentheses on the natural log, minus 3, close parentheses for the numerator, divided by the single 7. There's my answer, negative 1986,517,268. Does that make sense? Your next problem here is a logarithmic equation. This is what I call a type 1 log equation. Type 1 log equations are logs on one side equal to a number. Type 2 log equations are logs on both sides. Whether it's a type 1 or type 2, you always do the same thing. Combine logs. To solve a logarithmic equation, you got to get one log out of this thing. One log on one side, and if you need to, one log on the other. But this is a type 1 log equation. I only got logs on one side. So here we go. Addition. What is addition turned back into? Multiplication. What is the base on this log, even though they didn't write a base down there? This is understood to be base 10. And when addition turns back into multiplication, we're multiplying x times 4x. It's equal to 2. I'm going to clean that up. What is x times 4x? There you go, 4x squared. So this is the log of 4x squared equals 2. Again, what was that base down there on that log, even though I don't write it? You need to know what it is. What is it? 10. When you have a log type 1 equation, you get one log on one side equal to a number. The next step after you're getting your one log is you've got to get rid of the logs. What gets rid of logs? The smiley face definition. That's what gets rid of logs. So as I have y equals a log base b of x, I can rewrite that in the exponential form to get rid of the log. That's b to the y equals x. So to rewrite this equation here, log base 10 of 4x squared equals 2, I'm going to start with my base, 10, raise it to the other side, 2, so this is 10 squared, equals what you're taking the log of. What are we taking the log of? 4x squared. All right, let's do some basic math here. What's 10 squared? 10 times 10? 100. So 100 equals 4x squared. Now, what are you going to do to solve for x? Divide by 4. What's 100 divided by 4? 25 equals x squared. Now, get the x by himself. What would you do next? Square root. But remember, this is where most people will screw it up. Anytime you introduce a square root into a problem, you got two options, plus or minus. There's possibility of two answers here. So I'm going to take the square root of both sides. Anytime I introduce a square root, I got to do plus or minus. The square root and the square cancel. This leaves me with x is either equal to 5 or x is equal to negative 5. And there's my answer. But here's the deal. You're never done. When it comes to logarithmic equations, because logs have this domain issue, you can only take the log of positive numbers. You can't take the log of 0. You can't take the log of negative numbers. You always have to check your answer on log equations. You're not just checking to make sure it's right. You're checking to make sure you're not violating some rule of math like taking the log of a negative number. So I'm going to plug in 5 to the original equation, log 5. Well, 5's nice and positive. I'm happy. What's 4 times 5? 20. Log of 20. 20 is positive. I can do that. 5 is a good answer. However, plug in negative 5. Sometimes the negatives work. Sometimes they don't. The only way to tell is plug it in to see if it's going to be positive, or do you violate a rule of math by taking the log of a negative number. When I plug in x as negative 5, the log of negative 5 is a problem. I can't take the log of a negative number. And even over here, the log of 4 times negative 5. 4 times negative 5 is negative 20. I can't take the log of a negative number, so this is what we call an extraneous solution. So the only answer is x equals 5. Now, I just want to remind you of classic math on multiple choice questions and stuff. You know what they're going to do to you guys on the multiple choice. A, x is 5. B, x is negative 5. C, x is 5 and negative 5. D, x is negative 25. E, x is 10. I don't know. Whatever you can do with fives. 5 plus 5 is 10. You know, that type of thing. They just make up some answers after a while. So, but a lot of people on this particular problem would choose 5 and negative 5 because they would have forgotten to go back and check their answer on a log equation. Negative 5 won't work. The only answer is 5. Does that make sense? Take a look at number 4 here. I'll draw my little line here because I kind of ran over here. There we go. All right, on this particular problem, this is a classic problem. I've got e to the x minus 4 is equal to 4 raised to, this is a power, x to the 4 raised to the 2x divided by 3. It is an exponential equation. There's only one thing in the universe that brings down exponents. What's that? What brings down exponents? Property number 5 here. When you got something to a power, what's going to bring it down? Plugging a log in front of it. So in this particular problem, I've got e raised to the x minus 4 equals 4 raised to the 2x divided by 3. What log will I use to bring down this exponent? Why? Because I see an e in this problem, I'm going to use the natural log. So, as I rewrite this, e raised to the x minus 4 is equal to 4 raised to the 2x divided by 3. I'm going to take the natural log of both sides. The natural log and e cancel and brings down my exponent. X minus 4 is equal to the natural log of 4 raised to the 2x divided by 3. But now I'm going to use log properties. When I plug a log, regardless of log, natural log, common log, log base, whatever, in front of an exponential, where does the exponents get to go? To the front of the log. So this turns into x minus 4 is equal to 2x divided by 3 times the natural log of 4. So far, so good? Your mission, solve for x. This one looks nasty. Don't let the look of the equation bother you. Here's what you're going to do. You're going to solve for x. How do you solve for x? You get all your x's on one side. So what's my next move on this problem? To get all my x's on one side. Here's an x here. There's an x minus 4. I'm going to move that x to the other side. So what am I going to do? I'm going to subtract x from both sides. This cancels. It doesn't look any better. Here it is. It's negative 4 is equal to 2x divided by 3 times the natural log of 4 minus x. This is a great problem to study in terms of your preparing for the final exam. It's a crappy looking equation with x's in two terms. When you have x's in two terms that you need to solve for, you need to do what to be able to solve for 1x? Anytime I got multiple terms, terms are separated by addition and subtraction. Anytime I got terms separated by addition and subtraction, and I need to solve for the variable that's in both of them, I'm going to do the famous factor word. Factor the x out. When I factor the x out, I get negative 4 is equal to 2/3 times the natural log of 4 minus 1 times x. It's nothing but an awful looking number. All I did was pull the x out of it. So I've got negative 4 equals crappy number times x. What am I going to do to solve for x? Divide. And when I divide, I get x is equal to 2/3 natural log of 4 minus 1 all over, I screwed that up. It's negative 4 divided by, let me just rewrite that. It is x is equal to negative 4 divided by, on the other side, 2/3 natural log of 4 minus 1. And just because this kind of number screams maybe I should go decimals on it, let's take a look at what the answer looks like in decimal form. Turn it on, clear out the old one. It is negative 4, single term in the numerator, divided by multiple terms in the denominator. Put a parenthesis around it. Parentheses around fractions, 2/3 times the natural log of 4. Close the parentheses on the natural log guy there. Minus 1, and then close parentheses for the denominator. Notice how I typed it in on my calculator. And what do I end up getting? Awful number, 52.76783156. And that is my solution. Two different ways I could have written my solution. But the trick is, and you're going to see these guys when you have this something to a variable equals something to a variable, and I cannot get them as the same base. I can't get them as the same base. Then I'm going to do the log of both sides, bring down the exponents, and then pull all my x's on one side, non-x terms on the other, and then here's the key. The key is that word right there. Factor the x out of it, and then divide. All right, take a look at this next problem over here. Problem number 5. Problem number 5, and officially, you're supposed to have a parenthesis around that guy there. That's a little typo there. Okay, so I have this. Log base 7 of 3x plus 2 minus the log of x, log base 7 of x, equals the log base 7 of 4. Okay? This is what I call a log type 2 equation. Logs on both sides. When you have logs on both sides, what you want to do is you want to combine logs on the left side, combine logs on the right side, and then you get to do a wonderful math property. Cancel the logs, because whatever you do to one side, I get to do to the other. So this is what you do with log type 2 equations. Get the logs on both sides. Now this is subtraction. What does subtraction turn into? Division. This will be the log base 7, because they're both base 7 logs here, of 3x plus 2 divided by x. And this is subtraction turns into division, and this x goes into the denominator. Equals the log base 7 of 4. Combined like terms, the logs have to be identical. These are both log base 7s. What if the logs are not the same? You won't run across that. If that's the case, you use the change the base formula and then change it to the base that they are the same to do it on, but we won't give you that. We always give you the same type of logs. Whether they be log base 7s or over here natural logs, we always give you the same type of log on both sides. Now, what gets rid of log base 7s? I'm going to show you two different ways. I'm going to show you the mathematical way and I'm going to show you the real way. The mathematical way is this. This property right here. When I have a log base b of x here and I want to get rid of it, I want to convert it to an exponential. So whatever the base is on my log, I'm going to raise it to that log. What I do to one side, I do to the other. What is the base on my log on this problem? 7. So I'm going to raise this side, raise it to the power of the 7th power, the power of the 7. But what I do to one side, I get to do the other. 7 to the log base 7 of 4. And log 7 raised to the log base 7s end up canceling. And you're left with 3x plus 2 over x equals 4. Now that's the mathematical way we want to show you how the logs cancel. You just raise both sides to whatever the base is on the log, and they'll cancel the log. The real math way is this. What I do to one side of the equation, I do to the other. Since I have, listen to my words and you'll understand it better, the log of garbage is equal to the log of garbage, I can just cancel the logs and set the two garbages equal to each other. That's really what's going on in this one. I'm canceling the logs on both sides. Does that make sense? Now, here's the thing that should scare you, but it's perfect time for the old cumulative final exam review. How do you solve for x on this mess? I got variable 3x plus 2 over x equals 4. How are you going to solve for x? Because I can hide anything in a logarithmic equation. Quadratics, rational expressions, whatever. I can hide anything in this stuff. This works your algebra skills on how to solve for x. What method would you use to solve for x? What's your next move? Get rid of your fractions. Multiply both sides by x. What I do to one side, I do the other. This cancels. That leaves me with 3x plus 2 equals 4x. And now what am I going to do to solve for x? Subtract 3x from both sides. That cancels, and 2 equals 4x minus 3x is x. I get x equals 2. Does that make sense? Are you done? Never with a log equation, because log equations have domain issues. So you need to go back and make sure when I plug in the answer that I get that I'm not taking the log of a negative number. What's 3 times 2? 6 plus 2, 8. 8's positive, I can take the log of 8. Plug in x is 2, 2's positive, this works. What if I did all this wonderful, awesome math here and I got x equals negative 2? When I plug it in, I get 3 times negative 2, which is negative 6, plus 2 is negative 4. I can't take the log of a negative number, so this answer wouldn't work. Then the answer would be what? No solution. And that's perfectly legal math move in terms of log equations. You could actually do all this beautiful math, at the end of the day, your answer doesn't work. So check your answers. Always check your answers. And you're not just checking to make sure they're right. You're checking to make sure you're not taking the log of a negative number. Because all this multiply both sides, take the square roots, and all this other stuff has a way of putting these extraneous solutions in your equation. All right, let's take a look at this last one here. Another log type 2 equation. Here it is. I've got the natural log of x plus 1 plus the natural log of x minus 2 equals the natural log of x plus 6. Log type 2. I got logs on both sides of the equation. First thing I'm going to do is, on the left side, combine logs. This is addition. Combining logs, what is addition turned back into? Multiplication. This will be the natural log of x plus 1 times x minus 2 equals the natural log of x plus 6. Addition turns back into multiplication. So what do I have? I've got the natural log of garbage is equal to the natural log of garbage. I want to solve for x. What am I going to do? I can take both sides raised to the e's, but in essence, basically what I'm doing here is canceling the logs. Because log type 1s, I have to use the smiley face definition like I did up here. I've got, let's see here, Here it is. I got log base 2, log base 10, excuse me, 4x squared equals 2. I had to go 10 raised to the 2 equals 4x squared. That's log type 1. Logs on one side equal to a number. I can use the smiley face definition. Log type 2s, I combine logs and then I just cancel the logs. Officially, I'm raising an e to the natural log on both sides, so the natural logs cancel. But that does leave me with this. X plus 1 times x minus 2 equals x plus 6. How do you solve this kind of an equation? How do I solve x plus 1 times x minus 2 equals x plus 6? Well, the only one thing I can do, I'm going to have to multiply this thing out. Because the only time I have stuff factored, it better be equal to 0. We don't have this factor stuff equal to 0. I got to equal to x plus 6. So I'm going to FOIL this thing out. What is x times x? X squared. What's x times minus 2? Minus 2x. 1 times x is plus 1x. And 1 times minus 2 is minus 2 equals x plus 6. So that gives me x squared minus 2x plus 1x is minus x. Minus 2 equals x plus 6. What would you do now? Because you've just discovered, you know what was hidden in this problem? A quadratic. How do you solve a quadratic? Set it equal to your favorite number, 0. So I'm going to subtract x from both sides. And I'm going to subtract 6 from both sides. X gives me x squared minus x is a minus 2x. Minus 2 minus 6 is minus 8 equals 0. You got two options with a quadratic. The first option is factor it. Your second option is quadratic formula. On this problem, x squared minus 2x minus 8, what would you try first? Factoring it. Does it factor? What times what is 8 that differs by 2? X, I believe it's 4 and 2, right? And because it's the last term's negative, it's going to be plus minus, and because the middle term's negative, the bigger number is going to be negative, the smaller number is going to be plus. Equal to 0. You set each factor, x minus 4 equal to 0, and x plus 2 equals 0, and I get x equals 4, and x equals negative 2. Are you done with Mr. Log equation answers? Is the answer C, x equals 4 and x equals negative 2? Well, honestly, I don't know. What do I have to do? Check the answers. And I'm not checking to make sure it's right. I'm checking to make sure I didn't violate some log property about taking the log of a negative number. So when I plug in 4, go back to the original equation, not to any manipulation, but to the original equation. 4 plus 1 is 5. 5 is positive. Natural log of 5 is good. 4 minus 2 is 2. That's nice and positive. And the other side is x plus 6. So 4 plus 6 is 10. Natural log of 10, that's nice and positive. 4 is a good answer. That's a check answer. Negative 2. Negative 2 plus 1, that's negative 1. I can't take the log of a negative number. Gets even worse here. Negative 2 minus 2 is actually negative 4. I can't take the log of a negative number. But you'll notice on this side, negative 2 plus 6 is 4. It's positive on this side, but that's great. But once you violated one log property about taking a log of a negative number on one term, the answer is extraneous. That's a non-answer there. There's only one answer to this problem, x equals 4. Does that make sense? Questions? Okay. Let's take a look at section 8.1, the last section. Yay. The last section is basically solving systems of equations. Again, I know you've seen this stuff before, but I want to make sure that you guys are familiar with it. Solving system of equations. And typically there's two different methods of solving system of equations. Substitution method and the elimination method. And you need to be well versed in both of them. So, there are 3 different kinds of answers you can get with this stuff. basically, we're looking at linear equations. Linear means lines. So, from a graphing perspective, let me show you what kind of answers you can get. If I graph one equation and I graph the other equation, the solution for solving the systems of equations is called the point of intersection. So in this particular problem, we have a single point of intersection. We would consider this type of answer, we have a single answer. To have an answer is called consistent, and there's a single point for both answers. So this would be considered to be consistent because I have an answer. Okay? I have a unique answer. This would be consistent, unique solution. However, I could throw something weird at you guys, and I'm looking for the point of intersection, and I graph the two equations, and what do you notice about the equations? They're parallel. Parallel lines don't have points of intersection. So what is the solution for this guy? No solution. The fancy word for no solution is the word inconsistent. Inconsistent means no solution. That's another way of saying no solution. So there is a no solution for this thing whatsoever, okay? And I think we got a typo here. This actually belongs here. System, linear system with not solution. This part goes here. Sorry. But this is called, this stuff up here is correct. This is consistent, one common point. This is inconsistent, no points of the equation. Okay? And this one over here, the third thing I can get you. I got two equations. And when I actually look at the graph of both these equations, they end up being, they're not two equations, there's just one equation. They end up being the same equation. When you look for point of intersection, if they're the same equation, every point on this line is a point of intersection. So there's an infinite number of solutions. But there are solutions. Every point works. So we say it's consistent, but we use the word dependent. When it's consistent and one solution, we would say it's independent with a unique solution here. Consistent dependent means there's an infinite number of solutions on this thing. So how do I tell which one of the three cases I'm going to get when I solve system of equations? Well, let's take a look. All right, so here is my first equation. This is what I got. I got two equations. I got 2x plus y is equal to 5, and I have negative 4x plus 3y equals 5. I want you to, quote, find the solutions. Okay? How do I do that? Well, this one, they're asking me to do the substitution method. The substitution method is a method of taking one equation, solving for one variable, and plugging it into the other equation. Because you can only solve an equation in terms of one variable. Does that make sense? So I got to rewrite my equations with just one variable in it. Right now I got two variables. I got 2x plus y equals 5 and negative 4x plus 3y equals 5. Now with these two guys right here, I'm going to pick the easiest equation and I'm going to solve for one of the variables. Which is the easiest variable to solve for into which equation? The first equation, 2x plus y equals 5, the easiest thing to solve for is the y. How do I solve for y? I'm going to subtract 2x from both sides. This gives me y is equal to negative 2x plus 5. What am I going to do with this guy? It's called substitution method. Take this equation and plug it into the y of your other equation, substitution. This is going to give you negative 4x plus 3 times y, but y gets to be replaced with negative 2x plus 5 equals 5. Substitution. But what you've got now is an equation with just one variable in it. How are you going to solve for x? What's your next move? Let's practice some algebra here. I'm going to distribute the 3. This gives me negative 4x minus 6x. 3 times a negative 2 is a negative 6x. And 3 times a 5 is a plus 15 equals 5. Combine like terms. What is a minus 4x minus 6x? What's minus 4x minus 6x? How much you got? Very good. Minus 10x plus 15 equals 5. I'm going to subtract 15 from both sides. That cancels. That gives me negative 10x equals 5 minus 15 is negative 10. Then I'm going to divide by negative 10 on both sides. Negative 10 divided by negative 10 is 1. But when it comes to solving systems of equations, and we have a solution, we want the solution in ordered pair format. So any kind of solution would be this point of intersection. We want an x, y equation. So, what did I get for x? What's x equal to? 1. So my answer is x is equal to 1. What does that make y equal to? Well, you go back to what would that linking of that first equation where you solve for y, and you know now x is 1 and substitute it in. So y would be equal to negative 2 times x is 1 plus 5. So y equals negative 2 plus 5, which is equal to 3. So I get x equals 1, y equals 3. And traditionally, we like to write this as an ordered pair. So this would be my solution. X is 1, y is 3, is the point 1, 3. This is not interval notation. This is point on the Cartesian coordinate system. X is 1, y is 3. Does that make sense? Substitution method. Take one equation, solve for one variable, then plug it into the other equation. The other method is elimination method. Elimination method is, we have a whole class based upon this concept called linear algebra. The idea of lining up variables in terms of the equations. This is they're using elimination method. Okay, so what are the properties of elimination method? You can interchange two equations in the system. You can put one equation on top, one equation on bottom, or vice versa, it doesn't matter. The other one is you can multiply and divide each equation by the same non-zero constant, by any non-zero constant. What I do to one equation, when I do something or other, you can multiply the other equation by another. But the key to it is what I do to one side, I do the other. But the trick is what you're going for is elimination. You're trying to get two different equations, but one of the variables is going to have the exact same coefficient in front of the variable, but the signs will be opposite because you want to add equations to be able to eliminate a variable. Let me show you. I've got this equation. I've got 2x plus y equals 5, and underneath it I have the second equation. Negative 4x plus 3y is equal to 5. Okay? Notice something, brother, very important. My variables line up equal to my constant lines up. They're in the same format. I want to do elimination. I want to be able to add these two equations together to eliminate one of the variables. What's the easiest variable to eliminate? I go after the x's. To eliminate, you want to have the same coefficient except opposite signs. This x is already positive, that's a 2x. This x is negative, that's a negative 4x. But to be able to get the same coefficient but opposite signs, I need to take this first equation and multiply it times what number to get that 4? I'm going to multiply the equation by 4. What I do to one side of the equation, I do to the other. That makes it perfectly legal. So sliding this over, I'm going to distribute that 2 over both sides of my equation, and that's going to give me 2 times a 2x is a 4x, 2 times a y is a plus 2y, equals 2 times a 5 is a 10. The bottom equation we didn't touch, so that stays the same. Negative 4x plus 3y equals 5. Now, the ultimate goal on the elimination method is to get the same equations underneath each other with one of the variables having the same coefficient but opposite signs. Because now, what I get to do is I'm going to add my two equations together. The purpose of adding the two equations together is to eliminate one of the variables. The equal but opposite signs eliminates that. What is 4x plus negative 4x? What's 4x minus 4x? It cancels. But now add up the rest of them. What is 2y plus 3y? 5y equals what is 10 plus 5? 15. It gives you another equation, but in terms of just one variable. Now you can solve for y. Solving for y, what would you do? Divide by 5 on both sides. And that leaves me with y equals 15 divided by 5 is 3. Does that make sense? But, again, I don't care what method you use, the answer for this stuff is always an ordered pair if you can get it. I want an X and a Y. I got the Y, now Y equals 3. To get the X, I'm going to go back to either one of my two equations and back substitute. Doesn't matter which equation I use, I'll get the same answer. I'm going to use the easier equation though. I like 2x plus y equals 5, smaller coefficients, you know. So I got 2x plus y equals 5, but I know y is 3, so I'm going to plug it in. As y equals 3, we substitute 2x plus 3 equals 5. Subtract 3 from both sides. That leaves me with 2x equals 5 minus 3 is 2. And then I divide by 2 on both sides, leaving me with x equals 1. And there's my answer. X is 1, y is 3, or the 0.13. What a surprise. It's the same exact two equations we just worked a few seconds ago. I'm getting the same answer, but there's two different techniques to get this answer. Does that make sense? Well, how can they mess you up then? Word problems. Let's try this problem out here. Karen empties out her purse and finds 45 loose coins, consisting entirely of nickels and pennies. That's just like me. Nickels and pennies. Can't have a quarter, nope, because you can't buy anything with nickels and pennies these days. So nickels and pennies. If the total value is $1.37, okay, how many nickels and pennies does she have? All right. So it's a word problem. What's the first thing I'm going to do to a word problem? Read the problem and then give myself some variables on this thing. My two favorite variables are x and y's. So I'm going to let x be equal to the number of nickels. And I'm going to let y equal to the number of pennies. That's where I'm going to start. All I've got is nickels and pennies. But from stating what the variable is, I want to come up with an equation. What's the first thing they told me about these nickels and pennies? I have 45 of them. X is the number of nickels, y is the number of pennies, so that tells me from this first part, x plus y is equal to 45. If I add up the nickels plus the pennies, I got 45 coins. But the next part's going to require you guys to be able to do some math in here. And it's business math, so let's hear. The other part is the total value of coins is $1.37. So now we're talking about value. What is the value of a penny? 1 cent. So the value of the pennies is going to be equal to 0.01, 1 cent, times y, the number of pennies I happen to have. The value of the nickels, how much is a nickel worth? 0.05. Right? 0.05, 5 cents, but for 5 cents for every nickel that I have. How many nickels do I have? X number of nickels. So if I take 0.05 and multiply by my X nickels, that's how much money I got there. And if I take 0.01, multiply it times Y, that'll tell how much money I have in pennies. Does that make sense? So, for example, I got 5 nickels. What's 5? They're worth 0.05. If I got 5 nickels times 5 cents, how much do I have? 5 times 5? 25 cents of nickels. Okay? If I have 10 pennies, they're worth 1 cent apiece. 10 pennies times 1 cent, I got 10 cents worth of nickel, 10 cents worth of pennies. Does that make sense? But now to get my equation, the word total means add. Never forget that. So when you're trying to total something up, you want to add it up. So the total amount of money I got is $1.37. So I'm going to add my nickels, 0.05 times X, that's the amount of money in nickels, plus the amount of money in pennies, 0.01 times Y, that's equal to $1.37. Now I have a system of equations. I would like to eliminate a variable. It doesn't matter which variable I'm going to eliminate. I'm going to use the elimination method here because they line up nicely. I could use substitution. It's your choice unless I specifically state use the elimination method or the substitution method. So here we go. I'm going to use the elimination method because that's traditionally the method that is preferred in higher level math classes. Which variable would you like to eliminate? X or Y? It's your choice. Y it is. If you're going to eliminate the Y, you decided to choose Y, we're going to eliminate Y. The coefficient in front of the Y on the top equation is 1. The coefficient in front of the Y on the bottom equation is 0.01. I want to convert, but I want to make sure the coefficients are the same except opposite signs. So what I'm going to do here is this. I can either multiply the top equation by a number or the bottom equation by a number. Which one would you rather do, top or bottom equation? All right, let's use the top equation. I'm going to multiply the top equation by negative 0.01. That's, you got to make sure the y coordinate is the same, but the opposite sign. So when I do that, rewriting it down here, and I'm going to distribute, negative 0.01 times x is negative 0.01x. Negative 0.01 times y is minus 0.01y equals, now what is negative 0.01 times 45? You don't need a calculator for that. Maybe you do. What is negative 0.01 times 45? Negative 40.45? Okay, we'll use a calculator. These get people worrying me. Negative 0.01 times 45. What do you get? Yeah, negative 0.45. It just moves the decimal over. All right, a negative times a positive is a negative. The bottom equation is the same. 0.05x plus 0.01y equals 1.37. Look at your y variables. This is the ultimate goal on the elimination method. The y variables are the same except they have the opposite sign. So once I get the same but the opposite sign, what am I going to do? I'm going to add the two equations together, combine my terms. What is negative 0.01x plus 0.05y? I'm sorry, excuse me, negative 0.01x plus 0.05x. Very good, 0.04x. The y's end up canceling. Negative 0.01y plus 0.01y is 0y equals, keep the equal in the same spot, 1.37 minus 0.45. Negative 0.45 plus 1.37 is 0.92. So I got a single variable equation. 0.04x equals 0.92. What are you going to do to solve for x? Divide by 0.04. Now, remember what x represents. X is the number of pennies. I can't have a half a penny because that would be bothersome and maybe not worth anything because somebody cut it in half or whatever. So I'm expecting a nice whole number on this thing. Let's see what we get. 0.92 divided by 0.04 is a nice whole number. What did I get? X equals 23. What do I got to do to get y? To get the y variable, I'm going to go back to either one of my original two equations. Which one looks easier to you guys? X plus y equals 45 or 0.05x plus 0.01y equals 1.37? The easiest equation to me is x plus y equals 45. So I'm going to grab that equation. X plus y equals 45. And I know what x is. X is 23. 23 plus y equals 45. Subtract 23 from both sides. And I get y equals 45 minus 23 is 22. And that tells me this. X, which is the number of nickels, equals 22. I got 22 nickels. Y, which is the number of pennies, equals 23. I got 22 nickels and I got 23 pennies. Or, sorry, Karen has 22 nickels and 23 pennies. Personally, I got nothing because I got no change in my pocket. Does that mean? Oh, did I write it back? I did. Thank you. X is 23. Sorry. Thank you. Typo on my part. X is 23. Y is 22. Thank you. Excuse me. I'm richer than I thought. I got 23 nickels and I got 22 pennies. I still got $1.37. Does that make sense now? Now, don't forget to write them in the right order. That's just me kind of running through this thing too quickly. Does that make sense? Did I lose you guys anywhere? All right. So how can they make your life miserable? Try this problem. All right. And honestly, this problem is a problem that I stole off of the GRE. Are you guys familiar with the GRE? That's right. You got to take, you remember you had to take the SAT or ACT to be able to get into undergraduate college? To be able to get into grad school, you got to take an equivalent SAT called the GRE or the GMAT. There's several different versions of the thing. And this is one of the math questions on how to get into graduate school. So let's see if we can figure out this answer to this question. Eliza's mother is 20 years older than Eliza. By 3 years younger than Eliza's father, I think it's supposed to be but 3 years younger than Eliza's father. Eliza's father is 7 years younger than 3 times Eliza's age. Question is, how old is Eliza? All right. Okay. So let's see if I can figure this thing out. First things first. If I'm going to do this problem, first I got to figure out the English on this thing. But the first thing I want to do is figure out, I need a variable on this guy. All right? So I'm going to let x be equal to age of, okay? All right? Liza's mother's 20 years older than Liza. So I get y, I'm going to let be equal to, okay, y is going to be equal to Liza's mother's age. And I'm going to let, I also have her father up here. I'm going to go for 3 equations. Z is equal to Eliza's father age. So let's see what we got here. Eliza's mother is 20 years older than Eliza. So I need a first equation. Eliza's mother, that's y, is means equals 20 years older than Eliza. And Eliza is x. So I got my first equation. Y is equal to 20 plus x. So what I did here was I wrote down everything that I have, I wrote down a variable for it. All right? Let's keep going. But 3 years younger than Eliza's father. Okay? By 3 years younger, I'm not sure what that by thing there is. Okay? Eliza's mother is 20 years older than Eliza, but I think it's about 3 years younger than Eliza's father. All right? I think it's supposed to be the word but. And this is an English game, so welcome to the wonderful world of GRE. So we're talking about Eliza's mother. She's 20 years older than Eliza, but 3 years younger than Eliza's father. So how do I write an equation for Eliza with Eliza's father? Eliza is y. She's 3 years younger than the father. Will give me an equation. Y is equal to z minus 3. Liza's mother is 3 years younger than her father. Does that make sense? The father is z, so that's z minus 3. And then I got, does that make sense so far? To figure out Liza's mother's age, you got to take the father's age and subtract 3 because the father is older. Okay, let's keep going. Eliza's father is 7 years younger than 3 times Eliza's age. I need an equation. Give me that. Eliza's father, what is that? What variable is that? Z. Is means what in mathematics? Equals 7 years younger. What is 7 years younger? Minus 7. Then 3 times Eliza's age. 3 times Eliza's age was X. Does that make sense? Did I lose you guys anywhere? Again, this is just rewriting English into equations. Now, solve. What am I going to do to solve this thing? I'm going to do the substitution method. Let me show you. I've got y equals 20 plus x. I got y equals z minus 3, and I got z equals 3x minus 7. I'm going to plug, substitute in for the second equation because it's got a z in it. Y equals z minus 3. I'm going to plug in for z, 3x minus 7. So this, when I substitute it in, I get y equals z, which is 3x minus 7 minus 3. Let's clean that up. When I clean it up, that gives me y equals 3x minus 7 minus 3 is minus 10. So I've got y equals 3x minus 10. But I got another equation for y. What do I have there? I got y equals 20 plus x. So I got y equals 20 plus x. So I'm going to substitute once again. I'm going to take that y and plug it in for the y plus 20 plus x here. And this is going to give me an equation. 3x minus 10 is equal to 20 plus x. All this work, and it's the same work we've been doing, whether I'm substituting or eliminating, I'm trying to get a single equation with just one variable in it. And I've got that. I've got x. So, what am I going to do to solve for x? What would you do first? I would subtract x from both sides. Cancels here. 3x minus x is what? 2x minus 10 equals 20. Now I'm going to what? Add 10 to both sides. That gives me 2x is equal to 20 plus 10, 30. Then I'm going to divide by 2, and that tells me x is equal to 15. And what did x represent? Age of Liza. So she is 15 years old. And once you got one, you can go and find the other ones. So remember, back substitute, I got y equals 20 plus x. But what was x equal to? 15. So y equals 20 plus 15, which is equal to 35. So Eliza's mother's age is 35 years old. And then z is equal to 3x minus 7. So z is going to be 3 times 15 minus 7. 3 times 15 is what? 45 minus 7 is 38. So Eliza's father's age is 38 years old. Does that make sense? Did I lose you guys anywhere? So again, this has major potential for future stuff, but just wanted to show you guys this. Okay? Now, we got still some time left in class here, and this is kind of my plan. So what I wanted to do was, let's take a look at the homework set that you guys have. When's it due? Friday. So let's take a look at it. There it is right there. I want to remind you about this thing, so I'm trying to give you guys hints on it and stuff like that. It's this, okay? The first thing you're going to have to do is go back and study, this is the chapter 5 stuff, about the leading coefficient and stuff like that. Your degree versus the leading coefficient. We've made ourselves a little chart. The degree on this thing is 4, leading coefficient is 3. Which is a positive leading coefficient, and the degree is even. So from that, go look up your pictures and stuff. All right, in terms of this guy here, basically this is a multiplicity question. If you look at your zeros, you set the function equal to 0, and you can figure out your zeros. You got zeros at 1 and at -2. But the powers are your multiplicities. When you have an odd power, the function crosses the 0. When the powers, the multiplicities are even, it touches. It looks like a little parabola or something like that. So All right, so with these guys, looking at the multiplicities, the 0 at 1 has a multiplicity 2, which is even. The 0 at negative 2 has a multiplicity 3, which is odd. So you can identify which is going to cross and where it's going to touch at. And this one's kind of doing the same thing, but backwards. You'll notice that you have a 0, an x-intercept, a root at A and at B. So I've got x minus A and I've got x minus B. That's the only roots I have. But because at A, the graph just touches it, that tells me that has to have an even multiplicity. That's x minus A to an even power. Over here at B, I got x minus B, and at B, I know I have to have a linear power, or I'm just going to a odd power, if you will. It could squiggle or it could cut right straight through. Okay? But the other thing is this. When you look at these things, you've got to talk about your degree and possibly a leading coefficient. So this guy here is x minus A, and like I said, this thing's coming in, it's got to be probably squared because it looks like a little parabola there. This is x minus B. But when I look at that, my problem is going to be that that's going to be like 3 and 1. This looks like a 1 power here. This looks like a 2 power, degree 3. But a degree 3 falls on the left and rises on the right. But the coefficient is negative. But like I said, I'm going in the opposite direction, so I need to put a negative into this thing. So with the negative, instead of having x minus b, I could have b minus x. So from this, I think you can probably figure out what the answers are going to be, which one it's going to be. Because this is, you have to worry about the leading coefficient. This is going up on the left and down on the right, which means my leading coefficients have to be negative. So instead of having x minus b, you can have b minus x, which is the negative of that. Negative 1 times x minus b is b minus x. So you're looking at between, answer is either b or d when you look at it from that perspective. Same idea on this one. What's going on here at, this is negative 1, but you have a little parabola here. And at 0, this one has a 0 at 0. So you're going to have an x factor on this thing. But it's shooting straight through, so it's squiggly or whatever. But you have to figure out what is my leading coefficient. But since I'm falling on the left and rising on the right, this thing better be odd, and it better have a positive leading coefficient. So I can tell you B and D should not be your answers. Again, I'm doing a combination of what the zeros and the power of these zeros with the leading coefficient stuff. So please go back and look at, you know, the end behavior type stuff here. All chapter 5 stuff. Here's one. What's the remainder if I take this polynomial and divide by x plus 1? There's 2 ways to do this problem. You can do, 3 ways you can do this problem. You can do long division and see what the remainder is. You could do synthetic division and see what the remainder is. The only reason why you get to do synthetic division is because what are you dividing by? X plus 1, what does that make the C value have to be? Negative 1. You can do negative 1 and do synthetic division in this thing. Or you could do one other thing. Remember what the remainder theorem said. That C value that you had in the synthetic division, is that remainder is going to be the same as plugging in that C value into your function. I can plug in negative 1 into this guy. Negative 1 cubed, 2 times negative 1 plus 1. Negative 1 cubed is negative 1. 2 times negative 1 is positive 2 plus 1. 2 plus 1 is 3, minus 1 is, get your answer. Okay, thanks for announcing it. But there you go. Does that make sense then? 3 different ways I could have done that problem. This one, solve the equation. But they're telling you what one of the solution is. So on this particular problem, solve the equation. I've got an x cubed. I want to knock that sucker down. But I know one of the answers is 2. So every one of these answers has 2 in it. But what I'm going to do is I'm going to use synthetic division and divide 2 into this polynomial, and then I'm going to get a quadratic. Because when you divide out by a single x term 2 out of an x cubed, you're left with an x squared. Then you're going to factor it. But if it doesn't factor, use the quadratic formula. If it does factor, the answer is either C or E. If it doesn't factor, the answer is either A, B, or D, because I had to use the quadratic formula on the quadratic. So the trick on this one is take x equals 2 and do synthetic division, divide it out, and then take the quadratic and then factor it. Remember that P over Q rational root theorem I talked about? P are the coefficients of A0. Q are the coefficients of AN, the leading coefficient. What are the factors of 1? What are the numbers that divide 1? 1 and negative 1. What are the numbers that divide 6? 1, 2, 3, and 6. Plus or minus, of course. So the P's over Q's, the plus or minus 1s divided by the plus or minus 1, 3, 1, 2, 3, and 6. So one of these guys is not going to be a P over Q number. Which one is not a potential rational zero? So write every possible way you can write a P over a Q, and one of these numbers will not be up here. Circle that answer, because I emphasized the word not. Okay? All right, on this particular problem, again, do you understand where I stole these problems from? I stole them off of old final exams. So all I did was go through old final exams and grabbed questions from test 4. So study this thing because you're also preparing for old final exams. This problem right here, you were supposed to find the zeros of this polynomial and then add them together. How do you find zeros of a polynomial? By looking at the graph. What is the zero of a polynomial? Where it crosses the x-axis at. So here we go. So I'm going to clear my calculator out here. I'm going to type this equation into it. X to the 4th minus 2x cubed minus x squared plus 2x. And to let you guys know, I'm actually graphing this equation. I just typed it in on my calculator, and I'll blow it up for you guys to see it. There is my equation right there. If you want to find zeros of a polynomial, you should always be looking at the graph of this thing. I'm going to do a zoom 6 on it. What are the zeros of my polynomial? It looks like it crosses at -1, at 0, and 1, and at 2 by looking at the hash marks. So, and you can double check by doing the synthetic division if you need to, or you can blow up your calculator, whatever one you're going to do. But they wanted you to do something else. This is classic way they like to do the final exam. Add the zeros together. What is -1 plus 0 plus 1 plus 2? 2, huh? Yep, that's a distinct possibility. Okay. Does that make sense? Show your work. Graph it on your calculator. Draw the graph on the test. Yes. 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 I'm sorry. Let's go back and look at my major thing that I put up here. Homework number 3 is due when? Friday. Test is on Monday. So study hard on this stuff. And also go over this thing. And I may add, if you guys have a particular question about the homework set, bring it on Wednesday. I'll help you out with this thing. The main thing is get you guys prepared for the test. See you guys then. What was that question? When is the web test is going to be due the day of the test, which will be that Monday. But it's a day of the test or that evening. We just opened it up. I haven't adjusted any dates yet.